Right, so we'll start with data management evolution. Okay, and I'm going to do a quick revision, and then second paper, if there are any question related to data management evolution, we are going to do. Okay, right. So for this topic, I haven't shared you our note. Right, rather we rely on the UCSC note. Right, so this subject is all about beyond relational databases, but we discuss it only at theoretical level. Little bit practical level for MongoDB, NoSQL databases, but we didn't discuss anything practical for NoSQL databases or the XML-based databases or graph type databases. But if you want, you can use MongoDB as graph type databases as well. Okay. Right. So we started with the object-oriented concept because object-oriented databases are also not really relational databases, right? Why object-oriented databases came? Because in 1990s, object-oriented concepts dominated and still for general software development, but relational database systems evolved in 1970s, 80s. At that time, no concern about objects. Okay. So remember, in object-oriented programming, we encapsulate both attributes and behaviors or structure and operations into one unit called class. So related things, say payment related things, payment class, order related thing, order class, customer related thing, customer class, and so on. And of course, relational the database systems evolved as network data model, first acted hierarchical model, network model, relational model, and then the need for support for object oriented. Okay, because there was a mismatch, database relational, programming object oriented. Still that mismatch is there, somewhat that mismatch is there. Okay, if you are using relational database like MySQL. So these are some object oriented systems like Orion, Gemstone. Right? So remember object classes are there to create objects. So each object maintain its own state. Each object has its own uh, operations. Okay. And there are two type of objects. Some objects exist simply to process something, like control objects, UI objects. Okay. So there's nothing to save about it. But there are some objects at the end of a transaction, we need to change the updated value or new objects are created and so on. So how do you identify those? Transient objects are those you don't need to save it, like UI, JFrame, or controller in MVC architecture. Those are transient objects. So they just help the UI or any other control flow. But domain objects are persistent objects like order, customer, like employee, student. So just you need to understand this, okay? You can't memorize these subjects. So then for persistence objects, not for transient, we need to identify it uniquely, each object, right? So this particular customer, that particular customer, this particular payment, that particular payment. So therefore, persistence object needs a special state or attribute that represent the identity of the object. So that can be customer number, student registration number, payment ID. Okay, so that is called object identifier. And ideally, it must be generated by the system in a sequence, next payment ID. Okay. And most of the time, this is hidden from to the end users. That is fine. But internally, we need to keep track of that. Okay. Especially when they are related. One object is related to the other. Okay. Right. So therefore, object ID must be immutable. Immutable means you must not change it. Right. You must not change an customer ID, account number. But balance can be changed. But interest rate can be changed. So therefore, it must be immutable and unique. So those are the two properties for object ID: unique, immutable. That means must not be changed. So then others are called literals. So basically, not only others. If you assign a value to a field, that is literal, right? Literal, like a name, address, right? So your literal can be single value, like price, salary, department ID, or it can be structure. That means it's a complex literal, like address, maybe number, street, city. Okay. So that is a structured struct or tuple literal. That means your literal has multi parts. Multi parts. So then collection literals, that means that field needs multiple values, like multiple contact numbers, multiple skills. So this is at object level, right? This is at object level. Maybe in relational level, what we do is for collections, we go for one-to-many relationship, right? For structures, again, if you want, you can go for multiple different table, or you break it into different fields. Remember the first normal form? In first normal form, so it must be broken into fields, right? If it is single valued or atomic type, so the data type can be string, float, double, boolean, and so on. So you must familiar with this. Is not a specific language. This is pseudocode. Something like pseudocode for object databases, because still object databases are evolving and there's no dominant database management system. Okay. So if it is a structure like that, this is if you have a single value atomic field, but if you have structure in your class or type, so you say struct, this is pseudocode, okay? Your structure name and the structure, each field and data type, because in the exam paper you need to understand this and know exact syntax in pseudocode. So this is a structure. So usually we use struct in pseudocode. Then the collection, that is your field has multiple values. So there are few possibilities. What are those? Set, bag, list, array, dictionary. Okay. So you must know exactly what are the differences. For example, set, unique, cannot be duplicated. And order is not important, or order is not maintained. Set. Bag, there's nothing called uniqueness. Okay. But still it is unordered. So that means can duplicate, but unordered. Order is still like set, it is unordered, but set need unique, no duplicate, but bag can have duplicate. So basically, bag accept anything, even duplicate things, duplicate values. So third thing is list. So list, now it is ordered. These two are not ordered, but list is ordered, but list also accept duplicate values to different index values. So then you have array. Arrays are very much like list, right? Ordered. Ordered means it maintained the insertion order. That means you can access it using index. At the same time, duplicates are allowed. But most of the languages, arrays are fixed size. whereas list is dynamic, global. Okay, global. So there's a maximum size, that means fixed size. Okay. So then the last one is dictionary. Dictionary is like in Java, map, key value pair, key value. Remember in array, list index is maintained by the system, but in dictionary, we can provide the index value also, both index and value. So we have better control, but at the same time, it is additional overhead for us also. But if you want that better control of the index, like name and marks, say Nimal 100, Kamal or January, waterfall, rainfall is 200 millimeters. So then we can go for dictionary so that we have better semantic meaning for index. Okay. So it can be set, list, right? Bag, array, dictionary, or any other primitive. Okay. So this is sort of a complex definition of a type. This is not a class. There's a difference between type and class. Right? Can someone tell me what is the difference between type and class? Because now you should have studied these things, right? What is the difference between type and class in object databases? So type cannot have behaviors. Right? Type is a complex type. But once you add behaviors also, so then it become a class. Okay. So this is a type, defined type, your type name. It's like a complex type. So then you have the tuple, right? You can have simple types, right? Like string, integer. Then you can have collections, sorry, structures, right? So this is manager is another type you are referring to. It's called tuple, right? So remember, tuple is different from structure, right? So different from structure. You can call it, but if you are referring to another type, usually we call it rather than structure. If it is a structure, all these must be primitive types. Primitive types. But if your structure referring to another type, usually you call it rather than structure, you call it uh, tuple. Okay, so that means it's related. Its department is related to a manager record. Manager record. Right? So this is complex value, not a record. Okay, so struct. Sometimes we interchangeably use both struct and tuple uh, loosely. Okay, and these are multi-valued locations, right? Set. It can be set. It can be list. It can be dictionary. It can be bag. It can be array. Again, it can be set of primitive values or set of uh, other types. So that means, so these departments, employees. So employee is another type. So remember, it can be a primitive type or another type, another type. Okay. Right. So these things are something we have already discussed in semester one. Right? Encapsulation. That is the whole idea behind object orientation. You encapsulate data and operations to one unit. Okay. One unit. And some of the attributes can be visible. Some of these attributes can be hidden, private. And same methods also can be visible and private, like private methods, public methods. So then class is you encapsulate related attributes and behaviors of one concept into one class, right? One class. Remember, class can have both attributes and behaviors, whereas type cannot have behaviors. Okay. So class can have the object constructor, destructor, right? In addition to attributes. Okay. In Java, you don't write destructors, but in language like C++, you can write destructors. So destructor will be called, even in PHP, we discussed, right? Underscore underscore construct and underscore underscore destruct. So destructor will be called when the object is garbage collected. So then object modifiers are basically setters. So those methods modify the state or attributes. And retrieve means you get values, like get balance. Okay. Right. So this is a definition of a class. Define class. So that means you are going to define a tuple plus operations. So, okay. So this is your tuple. Start here, ends here, and then you have the operations. So tuple is, you can have primitive types. Your tuple can refer to other tuples. Uh, Composite type like set, list, and so on. Okay. Most of the time we use the word tuple because you can see employees there. This is okay, but this is another type. And then operations. Operations. So there you just give the operation name and the return type. Operation name, return type. Return type can be a primitive type, or return type can be another type. Okay, another type. And also you can have parameters. Parameters. Say assign employee, you need to give the employee a return boolean. This is department. This is department class. That is, you assign an employee to the department. So usually you don't write get number of employees like programming. So it's just say number of employees, but it really means get number of employees. Okay. So these are some operations. So you can see just say age, but it actually means get age. Right? Get age because return type is integer. Okay. Right. So remember there are two type of objects: transient objects, persistence objects. Persistence objects are the objects that we are interested in object databases. Now, when it comes to persistence object, you need to reach or identify the object to persist. So there are two options: by name, by reachability. So by name means if you have reference to object, say P1, payment 1, payment 2. So you can use that name or reference variable to persist it. This is usually using object relational mapping. But there are other situations you don't need to refer to it by name. Say one object is referring to another object. Say there's association between uh, customer and payment, or payment and order and payment, order and order items, many. So then you would just refer to order, and order has a reference to order item. So when you save order, automatically order and order items both saved. When you load an order with particular object identifier, order ID, you can it will make sure that it load both order and order items. So that means here we refer to these by reachability, not by name. This may be yes name. Okay, name this, but this one is by reachability. So that means when you load an order by sending order ID, you get more, not only order details, you get order item details as well. if maybe if there's a payment related to order, you can make sure that the payment details are also loaded. Or when you do a save, you save order items, payments, everything together. Or you have the control whether you need to reach this or not. So there are concepts like that in relational object relational mapping. For example, in Java, uh, you can do it using Hibernate, JPA, Java Persistence API. So you'd have those kind of things in semester four, right? Semester four, because you have the enterprise application development. That is one of the hardest topic in, actually, that is the hardest topic in semester four. Okay. Technical topic. So there you will see these things in practice also. Right? Naming mechanism, you directly refer to the object reference, or reachability, because your object has associations, aggregations, compositions with other objects or classes at class level. So when you save A, not only A, maybe set of B objects are also saved. When you load A, not only A object, set of B objects, so even some another C object is loaded. Okay. Now, if you have any questions, you need to ask. Okay. Right. So then we look at inheritance. Right? Inheritance is creating hierarchy of classes so that subclasses inherit or get non-private attributes and behaviors. That is at programming level. Okay. So you know the terminology, super type, subtype. Okay. So this is how you write it in pseudocode in object databases. Say employee subtype of person. So that means you have a type called person. So your subtype is employee. Maybe your subtype is student. This is person. Employee subtype of person. Because in second paper you need to write answers. Okay. Uh, because it's not only the MCQs. Right? Student subtype of person. And these are the additional field. So some fields will already you have defined your person type. So addition to those attributes, you have employee ID and salary for employee. Addition to the general fields for person like maybe a name, address, student will have registration number, index number, GPA, right? Okay. So this is geometric object, name, color, area, calculate area. This is a behavior actually. Okay. So this is subtype from geometric object, subtype of, and additionally it has radius. So that radius will be used to calculate the area. But in rectangular object, you have width and height. It doesn't have radius. So that will be used to calculate the area. Okay. So think logically. So remember there can be something called single inheritance, multiple inheritance. So single inheritance means a class can have maximum of one supertype. So this is single inheritance. The class can have maximum of one supertype. So language like Java support only single inheritance. But like all languages like C++ supported multiple inheritance. That means a class inherit from multiple classes or multiple types. So this is not supported in modern languages, right? Because of additional complexity, ambiguity. You remember the deadly diamond death phenomena? Okay. So multiple inheritance generate a type lattice. right? Type lattice. That means it's something like this can happen. This is fine. This is single inheritance. But the moment you do like this, there's ambiguity, whether that attribute coming from this side or that side. So there's a field here. Now that is inherited to this, but is it inheriting from this way or that way? Is it inherit because it is a subtype of this? Is it inherit because this is subtype of this? So that how do you define? So, so that kind of type lattice or diamond-like hierarchies are creating unnecessary complications. Okay, like this. Okay, so this one has even three. Right? You don't know a particular attribute coming from here or here or here. Especially if the same attribute is overridden also. But even without overridden, you don't have idea how it's inherit to this one. This because it is engineer or because it is manager or whatever. Right? There's ambiguity. Okay. Even it can for methods as well. Okay. So whether you need to use the overloaded version method of engineer or manager, because we are also both engineer and manager. Right? So likewise, you need to look at the practical issues. Right. There are some techniques to overcome ambiguity but modern languages, they completely throw away multiple inheritance. But those languages that support multiple inheritance, so they use certain techniques, workarounds. So one is check for ambiguity during the creation of subtypes and let the developer or the user specify the which version you want to inherit. So that means you need to specify, yes, I want this class want to inherit. Say there are two methods, same methods in engineer and manager. Here you can say it's manager's version we want to inherit, not the engineer's version. Though this both are the same method, same method signatures. Okay, so that is one workaround. Then system default. System default means always there's one class that is your default class. So then if there's ambiguity, you inherit from that default class. Okay. Third approach is if there's a that kind of ambiguity restricted. Multiple inheritance is supported, but when there's a conflicting situation, it is not allowed. That same method in two supertypes. In general, multiple inheritance is supported. So those are the three possible solutions or workarounds. But these days, mostly what we do is we completely uh, throw away multiple inheritance. Okay. Right. So this is a different concept, selective inheritance. Right? Selective inheritance. This is very rarely used concept. So selective inheritance means when you inherit something, say there's a non-public field or methods. So that means automatically you inherit it. But you don't want that functionality because it doesn't make sense to this particular class. So then you can accept or exclude that for this class. Okay, that this class for some reason. So that is called selective inheritance. You selectively inherit only some fields or some methods. Okay. So this is very rarely used and not facilitated in most of the object databases. Actually, not facilitated in most of the programming languages also. Okay. So it says these kind of things are more required in AI and that kind of things. Okay. Right. So then polymorphism. So remember polymorphism, we have two type of polymorphism. The kids polymorphism, most serious polymorphism. So simple polymorphism is operation no operator overload. So that means two operations with same name but different method signatures. So then depending on what number of parameters or data types, it call the correct operation. So this is within the same class. Okay, correct operation. So if you get a float, this method is called. If you get a float and that means two floats, this method is called. Or if you have something like int, another calc area method is called. So that is called number of parameters or by data types. So that is polymorphism, but that is operations or operator polymorphism. That is simple concept, but still it's operation polymorphism. That is polymorphism by overloading. The second type is the serious one with class hierarchies. That is polymorphism by overriding. Right, overriding. Now this is super type. These are the subtypes. So super type has calc area, maybe abstract method, not even implemented. But subtype have override, not overload calc area method. So if it is a circle object, this will be called. If it is a rectangle object, this will be called. So that is polymorphism by overriding, not overloading. Okay. So it is facilitated by dynamic binding. Only at the object time, it decides which method to call, not at compile time. Okay, dynamic binding or late binding. Right, that's it about object databases. So then we moved on to XML databases. So these are all uh, non-relational databases, okay, to support modern requirements of better flexibility because we no longer work only with structured. We now work with semi-structured, uh, even unstructured data. But remember, object databases are mainly for structured, structured, right? Relational databases are also for structured. But when we have semi-structured data, so the way to go is one type is XML or JSON. Okay, XML or JSON. So XML has better representation of the semantic because tag names are there and there's a very strict hierarchy. But JSON is little bit less strict, structured. That means we have a little bit more freedom, but at the same time, it needs less storage also because here if some most of the time same tag is mentioned twice, but here only once. There's nothing called tags. Okay, and so therefore these days mostly we use JSON rather than XML. Okay, but XML also useful because it's more structured. Right. So remember, these are structured data. Structured data. That is, relational databases, object databases are good for this. But for semi-structured data, like a web page, okay, menu of a hotel, it's more semi-structured data. Okay. So your semi-structured data can be tree data structure or graph data structure. So basically, XML mostly support tree data structure. JSON also mainly tree, but you can use it bit of graph structure as well. Okay. So what is the difference between hierarchy and graph? So in hierarchy, you have one parent. You can have any children, but one parent. But if a node is connected to more than one parent, not as a child, parent, so there's nothing called parent-child relationship. Those are just your neighbors. So then it's a graph. Okay, then it's a graph. So this is more, though they say it's a graph, it's more, yeah, this is basically graph. But no, it's not really a graph. You can see it's very hierarchical. I don't know why they call it graph, but it says directed graph. But I don't see any graph nature here. I see more hierarchical nature here. Okay. Anyway, they continue to use this, but for me, this is more a hierarchy because that's a leaf and parent as well, right? Right. Anyway, so then unstructured data is there's no structure at all or very little structure, very little structure. Lot of text, image, audio, video, definitely unstructured. So remember, HTML is pretty much semi-structured, but you can omit closing tags and so on, right? So that make it more and more unstructured. And a lot of text is used. The text itself is not structured. So then maybe we can say it's more and more unstructured. Right. So when it comes to XML, so basically what we discuss is XML, right? Not really anything related to XML databases. So in XML, we have tag hierarchy, root tag. Every tag must have a closing tag. There must be only one root tag. Additional information of a tag can be provided using attributes. Okay. There's something called elements, name constants. Okay. Sorry, not elements. Elements are tags. Uh, entities, name constant like in HTML, ampersand NBSP, ampersand GTLT. And that's your XML can be schema or schemaless. Schemaless means you don't define the meaning or the expected structure, right? Then it is schemaless. So any we can create your structure freely. There's no predefined expectation. But if someone defined this is the expected structure, then it is not schemaless, it's schema document. So schema can be provided either XSD or DTD, document type definition, or XSD. Okay. So this is XML document. Okay. Now it says it's hierarchical. Okay. XML is hierarchical, right? Not graph. But this data can be somewhat unstructured data, like a lot of text and so on. Right. So when it comes to XML, there are different categories, or we can look at your document as either data-centric document-centric, or hybrid. So data-centric means basically your XML document has data, like order details, customer details, payment details, but you put it into XML document. So that is data-centric. And usually they must be having predefined schema. This is the structure we expected for payment. Okay. So data centric is usually schema, not a schemaless. Right. So this is an example, product catalog. Sorry, projects. Project and each projects have project. Project has the product, sorry, name, number, location, department number, and who are the employees in that project. Another project, another project. So this is data oriented, data centric. Uh, for this kind of things, we can define our XSD or DT so that we expect that the data, your XML is complying with the schema. So then the document centric, this is data centric. Right? Document centric means it's a lot of textual data is there. Right? So very little structure. We can still call it semi-structure, but those textual things, they don't have any structure at all, like HTML document, HTML page. Hybrid means you have some parts are have a cement structure, but some parts it's semi-structured or a lot of textual things. So that's hybrid. Both structured data and unstructured data. Okay. Right. So in order to support more and more unstructured data, now we have NoSQL databases like MongoDB. We discussed MongoDB in semester 2. Okay. Under web, how to connect to MongoDB, how to insert, delete, update. So that knowledge you must have. Okay. So the main driving forces behind NoSQL databases are scalability, availability, flexibility. Okay. Because more and more we like to work, we work with semi-structured data. Okay. So in programming, we have one object related to has a association with another object or collection object. That object has a relationship with another object. So often what we work with is associations of objects, right? Customer, order items, maybe payment. Okay. So how do you persist this? How do you retrieve all these data, especially retrieval? Because when you want to show customers payment or order history and so on, so if you don't use structured relational databases, you need to write SQL for each or very complex SQLs with lot of joins. That is why you have inner join, now left outer join, right outer join, but it's make our life very complicated because then this is connected to another one. But that is the practical usage, right? For example, when you log into your e-banking system, it will show all your accounts, maybe your credit card, fixed deposit, savings account. If you have loans. So then for each account, it will show you the current overview, maybe last 100 transactions, last payments. So it's a complicated type of data, right? But relational databases, we rely on these foreign keys. So one table related to this, but these SQL can be very complex. So that is why we need more and more NoSQL databases where you can have the data like this kind of structure of data we can straight away retrieve, save, and so on. Okay. So that is another impedance mismatch. One is relational databases versus object oriented. Another thing is relational database versus object collections, associations. Because relational databases are not very good at handling these uh, structure of objects, object related to another object and so on. So NoSQL databases basically handle the second one, right? For the first one, you need object databases. If you want, you can use NoSQL databases as bit of object databases as well, but mainly NoSQL databases try to support the second impedance mismatch, that is object hierarchies, object collections, and so on. That is what we happen in programming. Okay. Right. So remember, impedance mismatch can be relational databases to object oriented or relational databases to uh, object graphs and so on. Okay. Right. So then, so these are two possibilities of applications. Your application, we have different applications referring to the same database. Right. So, but different applications may have different requirements as well. So there can be very difficult to provide consistent relational database structure that satisfy both these systems or another system. That is called shared database. Application database means your different systems have their own databases, and these systems communicate through web services. So that is another option. Both approaches has pros and cons. Here there can be duplicate of data, but better support for your system because its database is only specific to that and so on. Okay. So both has pros and cons. Okay. Anyway, those are the general process of NoSQL databases: scalability, availability, right? So scalability means when we have millions of records, millions of transactions within 1 hour, 1 minute, high scalability because you can have cluster of the same database in multiple clouds, and availability, especially through redundancy. Okay. So these are important, especially for big players like social media, global banks, right? And so on. Right. So there are different types of NoSQL databases as well. Right. So what are the main advantages of NoSQL databases? Scalability, availability, and also flexibility because it supports semi-structured data. Okay. Right. So these are subtypes: document centric, key value databases, column family databases. Okay. So remember the document database means it's like a document, right? Like textual data and that kind of things are supported. Key value means like key value, like shopping cart. It's more data oriented. Okay. Column families, now remember this is very important, provide a lot of flexibility over relational databases because each row is not required to have the identical columns. So in relational databases, every record must have the same column, but in column family, it's different. Different records can have different column families. Okay. Graph databases, when we need to save things in a very much like graph-like structure, like social media, friends, dependencies, project structures, project dependencies, and so on. So then what is polyglot persistence? So that means same application, sometimes we have different requirements. Sometimes we need graph-like a structure, sometimes we need key value-like structure. Okay. Sometimes you like to have a bit of hierarchy. So can the same database support these multiple things? That means can the same database support a key value, document, column family, all these? So if you have that kind of a flexibility, we call it polyglot persistence. So that we can pick and choose which internally what should be the structure. Is it key value or graph or whatever? Right? Because NoSQL databases keep supporting more and more of these internal structures. So then we should be able to decide which structure to use internally for that particular set of data. Okay, so that is called polyglot persistence. Use many data storage technologies to suit the data requirements. Okay. So this is a very important slide for your exam because there are a lot of questions. It asks, give you a scenario and ask which approach is the best. Those are very fussy as well. Even a little bit of guessing is needed because there are often maybe X also work, Y also work. But then always try to go by your slides and get hints. Like use a session. It says better to use key value, shopping cart, key value, or document. Financial data, better to go for relational databases because those are very structured, like transactions account. Point of sale system, again, it says relational databases because heavily data oriented, but at the same time, you can go for key value, document, or whatever for different aspects because there can be product catalogs and so on, maybe key value or document. Recommendations, graphs, product catalog, maybe documents because catalog are product catalog, right? Those are PDF and so, such things. Okay, so this is another one. Customer social graph, go for graph. Inventory management, go for RDBMS. All right. Orders, maybe RDBMS and document, like send in the order document. Shopping cart, key value. Okay. Right. So then you must know the difference between relational model and aggregate oriented model. Of course, relational model is the one that we use in relational databases. It's tuple oriented. You have records, and records are saved in tables. But when it comes to graph databases, especially graph databases, we go for aggregate oriented approach. That means a class is associated with another class, maybe many, maybe another association, one. Okay, so rather than association, now we call it aggregation, especially when it is many. Okay, it's aggregation of objects that you save. Okay, so one object is associated with another one. Maybe it's associated with many of the other things like object order has many payments, order has many order items, order item is related to product. So that approach is called aggregate oriented because if you go for relational approach, it's very complicated joins, very complicated database design. Okay. Right. So these are some examples of aggregate oriented, right? These are just examples. Okay. Order has many order payments. Order has many order items. Order item is related to product. Order is related to customer. Customer is related to billing address. And your order payment also may refer to billing address. Billing address refer to address and so on. And order also related refer to the address. Yes, it's very flexible. Unlike relational databases. Relational databases, we try to minimize the connections, right? So then, for example, if this relationship is not there, you need to go to this, and this, but now you can directly connect. When order is loaded, directly it can load address. Okay. So that gives you more flexibility. Okay. So relational versus aggregate oriented. Right. So more examples of when to use key value pairs. Okay. Right. So this is key value pairs, key value. And it can be nested also. Okay, nested. So all your shopping cart items are key value pairs. All the product catalogs are key value pairs. Right. So document data model is more suitable when you're working with more textual data, like documents, like PDFs. Okay. Right? So these are some scenarios for document like logging events. Right. So this is column family store. Remember, then each record can have different fields, different fields. Right. Content management systems, like blogs. So those are some usage scenarios. Like graph data structure, when you have a graph of connections like social media, right? Any other dependencies, like social workflows, user preferences, rules for eligibility, like in order to do this, you must have done these. In order to do that, you must have done these. So those are dependency graphs. So they have given some examples. Right, I don't think there are any second paper question on this. Okay, still it's not over. Right, object databases. So object databases are the closest to the relational actually. The only thing is rather than uh, just foreign key, we need bit of additional support like object identity, associ association, that kind of things. Right. So remember in database, relational databases, when you represent many-to-many relationship, you need a connecting table. But object databases, yes, internally it may be using connecting tables, but they try to hide those complications from you. Okay. Hide those complications from you. Right. So this is about XML databases. Okay. So XML has a bit of overhead because you need to store tags also, but at the same time, it gives you a good schema, right? Self-describing means it has a good schema. So there are tags, not just one tag, even two tags, which help you create the hierarchies. Right. Do you remember the difference? The schema plus versus schema supported. Right. So let's see whether there are any two second. I don't think there are any second paper questions. Then we can straight away take all the MCQs together. That is easier way because MCQ covered everything, right? Let's look at the last three past papers, second papers, 24 part 2. Okay, so let's do the second topic also and then look at the past papers because these from these two usually mostly you get the second paper question is from second topic or second topic and first topic together. Okay, so therefore now let's look at the second topic also and then we'll look at second papers. Okay, for those two topics combined. Right, database constraints and triggers. For that, I gave you a separate small note also. Award note also I gave you. Let me open that one also. Yeah, stored procedures and triggers. First, I will go through our note because it's a very short one, then UCSC note, and then we'll look at whether there are second paper questions. Right. So remember, stored procedures are programs running in the database. Stored procedures, you need to call it from your programs, right? PHP or Java or whatever. Triggers are also sort of a program, so many programs, but those are triggered by events. You don't call it, right? It's triggered by events. Like maybe after insertion of a particular record, insertion of a record into that of a table. Whenever record is deleted in say particular table, it's trigger. So you can set under which condition this trigger is to be called. But there are a lot of similarities because inside procedures and triggers, you can write your code even with if else loops and so on. But stored procedures are more versatile than triggers, right? So we refer to the Oracle. The way we write triggers, stored procedures in different databases are slightly different. Now we are in the relational databases, but Oracle is the most versatile uh, database when it comes to stored procedures and triggers. So that is why we refer to trigger Oracle, or we call that PL/SQL language. Your nodes have not referred specify a particular language, but most of the past paper questions are more Oracle PL/SQL. Okay. So you can see you can call the stored procedure, then stored procedure execute things in the database. Stored procedures can have any SQL statements in addition to if else conditions and so on. But triggers, you don't call it. You do an operation, then the database itself will trigger that. That is the difference. And also stored procedure can return you something, but trigger can't return you anything. So this is very important, right? Understand. So otherwise you blindly memorize things, right? Blindly memorize things. Okay. Now you can get a feeling of what kind of approach you are doing. For example, if you have good results for uh, theory subjects and less results for technical subject, that means you are more focusing on exams rather than how the industry work, or you don't think much about your career. That means you get good results for information system, bad results for programming. Sometimes there are students, they got good results for information systems and even sometimes technical subjects like programming, but maths fail. So that means you have a bit of issue with your abstract thinking, right? So likewise, you need to find out your weak points and maybe fix it or attitude issues. Okay. But in any subject, at the end of the day, you must rely on your understand, right? Not memorizing things because memorizing may sometimes make pass exams, but it make you very stressful person, right? Very stressful. You are under a lot of stress, but you somehow try to overcome it. But when you rely on understanding things, right? So that make you very relaxed person. Always there's a bit of stress when it comes to exam. That is normal. That stress actually help you improve your capacity. But if you 100% or more than 50% rely on memory, it make you a very stressful person. Okay. You are under a lot of stresses. You keep trying to memorize this and that without knowing why these things are happening like that. Right. So we use the online Oracle because Oracle installation need a lot of resources. Of course, if you want, you can install Oracle. Right. So then we look at the basics of PLSQL, the code structure, declare, begin, end, and possibly exceptions. Okay. So you can declare your variables. And remember, data types are compatible with the database field types. So this is how you print something to the database log. DBMS output put line. මේවා කෙලිම ඕන වෙනවා. Okay. In Oracle. Okay. So then how to write comments? Of course, comment නම් ඕන වෙන්නේ ඔයාලට exam එකට. So data types are pretty much the data types supported by the database. Like number, real, varchar. In PLSQL, assignment is colon equal. Okay. Colon equal, not just equal. It is PLSQL syntax. Variable name, data type, initialization. If you don't initialize, that's fine. Maybe you later retrieve data and initialize. Right. So then you can have global scope that is available to your stored procedure. Local scope, that is you only use it inside this. Okay. So then you can write your SQL queries because stored procedures are executed inside your database. And you can use your stored procedures to load data to your variables. Like this. Say select name, address, salary into, this is not standard SQL, into these the variables you have already declared. Right? Right? From, this is again normal SQL, and you can have where conditions and so on. Now you have, when this is executed, your variables will have the values if your select statement return a record, or if your EID is a valid number. Maybe this EID you can send it as a parameter when you call it. Okay. So then you can print it. DBMS put line, that is writing it to the log database log file. This is how you concatenate in PLSQL. Okay. So then you run it. PLSQL වල අපි එතන ගිහලා run කරන්න පුළුවන්. නැත්නම් අපි ඔක run කරන්න කෙලින්ම PHP වල ඉඳලා Java වල ඉඳලා. හරි. හැබැයි එහෙම run කරන්න බෑ මේක. This is not a name stored. This is not actually stored procedure. This is a procedure. Procedure මේක store වෙන්නේ නැහැ. අපිට පේන්නේ මේක නමක්වත් නැහැ. This is a procedure. Okay, procedure. But in reality, what we use is stored procedures. Okay, stored procedures. Anyway, whatever you do with procedures, you can do with stored procedure. Stored procedure is a procedure that you save it by giving it a name and parameters and so on. This is just a procedure. මේ වගේ execute කළ බැලුවා. හරි. අර SQL වල තියෙන operators available. ඊට අමතරව මෙන්න මේ special concatenate එක තියෙනවා. And you have the case, loop, while, for, exit, continue. Okay. So these are valid PLSQL blocks. Right. You can see there we do a select statement and take the value to a variable eSal. And your data type can be, again, you can say this tables, this fields type is the data type of this. So then it's very easy because then obviously it is compatible rather than you tell the data type. Of course, if you want, you can tell the data type like varchar and so on, but this is the better approach. So this variable's data type is the employee table salary fields data type. Okay, because you are taking that salary value to this variable. And now you can write if condition, like if salary is less than 70,000, do this. Otherwise, don't do it. So you can have else part. At the අඩු නම් එයාගේ salary එකට 1000ක් එකතු කරන්න. Still, this is not a stored procedure. This is a normal procedure. මේක stored procedure කරන්න හරි ලේසි. ඔකට නමක් දානවා. ඒක හරියට method signature එක හදලා දෙනවා. Right, case is there. Right. These are PLSQL, okay? මෙතන database call එකක් කරලා නැහැ. Just to try to just for you to understand how the case works. Then loops are there. So this loop will never end in loop. So therefore you need to have a conditional exit. Otherwise this will be executing forever. You can see this print 10 to 50. The minimum explain කරන්න ඕනේ නැහැ නේද? Right. Start with 10, 10, 20, 30, 40, 50. Then next time it will be 60. 60 is greater than 50. Therefore it says exit this loop. So that means end this, right? After exit, what is X and end. Right. While loop, because here you rely on this exit, but while loop, when the condition falls, it automatically exit. Okay. For loop, if you want to run it predefined number of times, like 3 times, 4 times, okay, 10 to 12, that means 10, 11, 12. This run 3 times, first with A of 10, A11, A12. So exit we already discussed, then the continue. So exit will exit the nearest outer block. Right? We already use it in loop. But continue will skip the remainder of the current iteration and join the beginning of the loop. Okay. So it's same as Java continue. Okay. Nothing special. Right. You have arrays. You will call it var arrays of data type. Or this can be you can refer to a tables field. This is size 3. You can keep 3 values like this. This is varchars. Right. So this is the name of the array. So this is the name of the variable. You can create any number of variables of this. It's like a new data type. Okay. So this is another array you are creating. Okay. Right. So then what happens when it comes to stored procedures? So these are procedures. These are not saved, but you can execute this. So you just give it a name. Okay. Right. So you can say create or replace procedure, give it a name. So then this is saved in the database, just like your tables and so on. By create or replace, that means if the stored procedure is already there, replace it. If it is not there, create it. That is why we say create or replace. So then give the name. Okay, so then you give the parameter name, type, whether it's an in parameter, out parameter, or in out. So the next one, next parameter. And then you say is or as, then your block of your stored procedure. Okay. Right. So this is simplest, no parameter, no return. So now you can, in your Oracle environment, you can say execute, or even in your PHP, Java, you can call these stored procedures. Right? Just call these stored procedures from your program. So then it will be executed in the database. Okay? So this is how you drop a procedure, stored procedure. Okay. So parameter can be in, that means you are sending it, but you are not expecting the output. Out means you don't send a value, but you are expecting after calling that parameter has a value. In out means you are sending a value, and after the execution, you expect that, but if that value is updated, uh, new value is returned. This is not a return, but it's sort of a return also. The changes are you send 5, but maybe after the call, that variable, that parameter has changed. Your stored procedure has changed that value. Okay. So this is out parameter. So you are sending only two. Sorry. Uh, so you are sending only two. Sorry, you are sending only two values, but after calling, this parameter must have the value. So you print and see whether what is that value. Okay. But you must have declared that variable, right? You are not sending a value. No value is assigned, but after calling, before calling, C has no value, but after calling, C must have value because it's an in-out parameter. Sorry, this is an out parameter. And you don't need to return it, right? You just, if you have done some changes to Z value, that value is now reflected after calling. Okay, that is out parameter. If it is in-out parameter, you can send a value also. For example, you are sending A as 23, right? And there you your new x is x into x. So therefore, what you after calling, your A will have 23 square, 23 into 23. That is 529. That is in now because you are sending a value also. Your variable has a value. That value you can use. But at the same time, if you have done changes inside that, after calling, when you refer to this variable, it has an updated value, not the original value. Okay. So function is a special case of stored procedure where you can return value. Here also it's sort of a returning but implicit returning, right? You change value is there, but function can specifically return value source. Only thing is now say create or replace function. Okay. And you need to give the return type. Return type. Right. You can see create or replace function. Here we have not used any parameters. You can have parameters that then say return number. So therefore you must return a number. So then someone calling, they can, when they call it, they can assign the return value to a variable of the correct type. මේවා දැන් ඔයාලට තේරෙන්නේ නැහැ නම් කියන්න බෑ. Right. So then the use of cursors. So remember, you can write a select statement and get those variables into get the result into variables. Right. After insert into කියලා. Something like this. Select cell. Sorry, not insert into. Select blah 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 from here. You can say into. Now this is a normal variable where you get the value. But what happens if you don't have the where condition? So then multiple records will come. Or maybe your where condition satisfy multiple records. So then you can't just take that value into a simple variable like this. Okay. You can't do like that. So in that kind of a situation where your select statement returns multiple records, we can use cursors, right? We can use cursors. So cursors are heavily used in stored procedures. Or stored procedures and functions, okay? So there are two types of cursors in PLSQL Oracle, implicit cursors and explicit cursors. Okay. So implicit cursor automatically created by Oracle, and we can't control it programmatically. So whenever there's an insert, update, delete, implicit cursor is associated with this statement. Okay. Right. So these cursors will return you whether it's success, fail, right? That kind of how many records are affected by your update statement, delete statement, how many record deleted, whether it is found or not. Okay. That kind of things. Right. For example, this is an example. This is update statement. So the update employee salary equals salary plus five. There's no where condition. That means if there are 100 records in your table, employee table, 100 records will be updated. All records will be updated. Even if you have where condition, say department ID is 2, if department there are 10 department ID to employees, 10 records will be updated. Maybe there are no employees in that department, so then nothing is updated. So how do you get that kind of information, right? How many records updated, whether it has affected any record or not. So you can use implicit cursors. Okay. So there's an implicit cursor called SQL in PL/SQL. So it has some properties like not found. So not found will be true if none of the records are affected by your last SQL statement, right? Last SQL statement. Found will say that means it has affected at least one record. Row count will tell you how many records are affected or modified by this statement, okay? And so on. But explicit cursors are something we make, especially to get the return value of a select query, right? Return value of a select query. So then you need to create your cursor. Cursor, your name is your select state. So then your results will be taken to a sort of a two-dimensional array. Okay. So this is how you work with explicit cursors. You declare your cursor, open your cursor, fetch data from your open cursor, and close the cursor. Now this is a declaration of a cursor. It declares some fields also, simple variables referring to the tables types. Now we have cursor. So this is the name of the cursor is select. Cursor is always connected to select state. Right? Say ID, name, address from employee. That means all the records of the employee table, but you need only these three fields. Now you can open. Open means this select statement is execute. Right? So then the results are in this cursor, C underscore employee. Now you can use a loop condition because this is like a two-dimensional array now. Right? Fetch C employee, that is your cursor, into because you have three fields here, ID, name, address, to these variables. You have already defined those variables, right? And you can exit when not found. That is implicit cursor. Or not implicit cursor. Your cursor has a property called not found. Not found means when you keep fetching, right? At the end, you are running out of records. So then it will exit. Right? So that will iterate through all the records in the cursor, and when there are no more to find, it will exit. So make sure you close your cursor. Okay. So that will list down all the employees in that table. This is the standard way you work with cursor. Okay. So then you can have records also. So it can be table based or cursor based, because cursor can have complex joins also, right? Your cursor may join two tables, but table based means it's a simple cursor bind to a table. Right? You can see this is a simple select statement. Okay. Select all from employee, but we say employee rec into employee rec. This is not a cursor, right? But here we assume that you get only one row, because if you get more than one row, you must go for a cursor. But if you are pretty sure that you are going to get only one record maximum, you can go for a row type, right? Row type. So basically that means your where condition, you are restricting by primary key, because then only one record. So if one record is guaranteed, you can go for row type or record type rather than cursor, because cursor is when you are expecting more than one records as well. So then it's very easy. You don't need to open and blah, 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 iterate through. So just you refer to the dot notation, right? Employee rec dot ID, those are the table fields. You know what are the fields in the table. You don't need even have to declare them, right? So if you are pretty sure only one record is written, use row type. Still, if you want, you can use a cursor, but then that will only iterate once. But easier thing is go for row type. But if there's a possibility of more than one record, make sure you create a cursor and open, loop through and close it. Okay. And this is, you create a cursor. Remember, we created individual variables earlier while you create a cursor. So this is another approach where you create a cursor. Of course, this is going to give you more than one record. There's no where condition. But here it says employee cursor, its type, employee record is employee cursor's row type. So that means when you go through this cursor, loop through this cursor, each row, each record, you take it to employee variable rather than in extracting individual things, because then this is like object. Then you can say dot notation for this one. So that reduce the number of variables you declare, because now you have the sort of a 2D array, and each element or each one is this type. It's row type of this cursor. Okay, so then you can use dot notation because you know your ID name and address. ID name. These ID name and address are not the field names in the table. Your select values. Okay. Of course, this must be valid field names also. Otherwise, this select statement will. But basically, the idea is reduce the number of variables. Here we had to declare multiple variables. Now you don't need to do like that, because we have created another variable of row type. But this is not the table's row type. This is the row type of this cursor. Earlier we created a row type of a table. You can see employee tables row type. Right. But here we create a row type of our cursor, because you know what are the return values. Okay. Right. So then of course you can do exception handling. I did little bit more than in your node, UCSC node, because this is a very important area for your project software development as well. You can do exception handling because there can be exceptional cases when you execute these things, right? So there are some exceptions, predefined exceptions in Oracle. You can cache those and write some logs and so on. And when others means it's any other exception that you have not specifically caught here, handled here. So then it will go there. Okay. Right. So when no data found exception happens, it will write like this. If any other exception, because otherwise when there's exception, you don't know what happened. Okay. So there are some predefined exceptions in Oracle, right? These are one of the predefined exception. Right. So triggers are just like stored procedures, but stored procedures we can call triggers are auto-triggered. Okay, auto-triggered. So we can use triggers to enforce referential integrity, logging, okay, do some additional security related things. Actually, in MySQL, what happens is internally, when you have referential integrity constraints, those are internally implemented as triggers. So we don't write the triggers. You know that on update, cascade, and so on. So those are handled by triggers internal. But even we can write our triggers. So this is how you create a trigger. It's pretty much like stored procedure, but now we say create or replace trigger. Trigger name, then whether it's a before, after, instead of trigger, whether your trigger is related to insert, update, or delete, you can have multiple also like insert to update. Then which table, okay? You can have additional conditions. You can have your variables and then the code and even exception handling. Right? So in the exam, they ask about triggers mostly. But now you can use your stored procedure knowledge. Best thing is look at some examples, right? Say create or replace trigger, this one, it's before delete or insert or update. That means before delete or insert to update, this trigger must be triggered. Uh, so this is the standard way we write it for each row because your insert may have multiple record insertions, your update may affect multiple records. So therefore, we say that this trigger must check for each and every record, for each and every row. This additional condition, this is optional. So when ID is greater than 0, only do it. Okay. New ID. If it is insert or whatever. Then you can have your variables, then begin end, whatever the things here you can use while loop, for loop, if conditions, cursors, so whatever you want. But remember, there are two implicit keywords here, new and old. This makes sense for updates. Right? Old means before update, whatever the value in the table, that record. New means your new value. Say you are doing an update. So your update statement has a new salary value. So that salary value is this. So this is the current salary value for that record. New, old, colon, new. So we print old salary and new salary, and also the salary difference we can calculate to a variable, and we log it. So every time you do update, we log all salary. If it updates salary, we print the old salary and new salary and the difference. Okay. Of course, for inserts, there won't be any old salary. It will be considered 0. For delete, of course, there's nothing called new salary, just the old salary. So if you want to trigger this kind of a trigger, of course, you can execute this, then this trigger is stored. So then you can do an insert or something like that and see the log file or log console. Okay. Or you can write update because this is update also it work. So update, you have the old salary, new salary. Of course, if the old salary is 1,500 for this employee ID too, right? We did this, right? As a, now here you can see there's no old salary because this insert, therefore no salary difference. But definitely update, you have the old, new and difference. Okay. So then we look at assertions. Assertions. So where do we use assertions? It's a schema level constraint. Okay. So that must be satisfied when you do database operations. Okay. So assertions are more versatile, but assertions are not supported by a lot of databases because most of the time triggers are enough. Most of the time it's only specific to a table or record. But assertions, if you need to do some controls at global level, right? Global level, when multiple things are affected, right? Joins, subqueries, aggregates, and so on. Because it's very complicated process, a lot of databases, they don't support. Even Oracle doesn't support, right? MySQL. This is more theoretical aspect than practically used aspect because it's not practically supported by most databases. Okay. So therefore, rather than assertions, we go for check constraints, triggers, application logic, stored procedures, and so on. But theoretically, you must know the difference between uh, assertion and trigger. Okay. So this is global constraints. Scope is whole database, not specific table or view. Enforce cross-table condition. This is usually single table. Okay. So not supported directly. At least it's not visible to the users, developers. But anyway, in your note, UCSC note, they refer to assertion. So therefore, you must familiar with the syntax. Create assertion, the assertion name, and check Boolean condition. Okay, like this. Create assertion, this name. This also saved. Okay, this assertion is like a trigger. It's saved. It's a check not text is select all from employee where salary less than zero. Right. So that means you need to check whether if there's at least one record with employee salary less than zero, that has violated this assertion. So basically, it will not allow violating this assertion. Of course, this assertion is a very simple assertion, right? It's only referred to single table. This maybe we can even implement it using a trigger. And බලන්න පුළුවන් new value එක greater than 0 නම් අපි insert එක නොකර ඉන්න. Insert එක කරන්න නැතුව අපි ඕන log file එකට ලියන්න. But this is just a simple assertion. Because assertion එකේ syntax එක දැනගෙන අහලා තියෙනවා. So this is multi-table assertion. Create assertion name with check using a join. මේ join එක පාවිච්චි කරලා ආට record වෙනවද කියලා බලන්න. එහෙම not existed not. Okay. So this is another assertion. Mostly those are checks, okay? You can having and so on, right? Complex assertions. Right. So that's now let's quickly go through the UCSC note as well. Right. Database constraints and triggers. So the subject is not easy. Actually, not the subject. Paper is very tough. Right. මට දැන් මේ විනාඩි 10 විතර කරන්න පුළුවන්. different constraints, implicit constraints are there. That is inherent from these are very important for exam, right? Inherent constraint versus explicit constraints. So explicit constraints are things that we write, like in triggers. Implicit constraints are part of the relational model. For example, primary key cannot be duplicated. So if you try to insert a record with same primary key value, you get error. So that is an implicit constraint in relational database. If you have enforced for referential integrity, if you try to add, say, add an employee with department ID which is not in the department table, you get error. That is not something you write, coming from the relational theory. So those are implicit constraints. Those are enforced by database. But explicit constraints are more related to business rules. Database has no idea unless you write it right. Those things you can write in assertions, triggers, in your stored procedures, and so on. Okay? Right. These are some inherent constraints. Relation consists of certain number of simple attributes. Attribute must be atomic. No duplicates allowed. Okay. Some of these things you need to enforce through normalization, like first normal form. Okay, it's part of the relational theory, right? So therefore, it's a bit of a wrong saying that always database enforce it. Sometimes database enforce it, like referential integrity, entity integrity, but sometimes you need to design it in a such a way, especially like multi-valued attributes are not allowed. That is something you need to design. That means you must make sure that first normal form is not violated. Second normal form is not violated. Third normal form is not violated. Yeah, partly our tasks, partly databases tasks when it comes to implicit constraints. But those are part and parcel of relational theory. But if it is a specific thing for our needs, our business things, so then it's an explicit constraint. Definitely, it must be a trigger. Trigger or assertion. So sometimes we call them domain constraints. And domain coming from the domain. You can see check constraints. Gender must be male or female. NIC must be unique. This is not your primary key, but still you want to make it unique. Right? Some default values. It's also sort of a constraint. Key constraint, that is primary key, foreign key. Right? It can be composite primary key. Right? Integrity constraints. So that is basically primary key. That is, you don't need to execute that, right? Database management system will make sure that uh, primary key's value is unique, right? Not null constraints, right? Mathematical and then candidate keys, super keys. You can have write your own constraints. You can even give it a name so that you can drop the constraint. Okay. මේක මෙතන ලියන්නත් පුළුවන් මෙතනම ලියන්නත් පුළුවන් gender field එකේ check කියලා. Preferential integrity constraints, on update, on delete, cascade, set null, set default. Okay. This is referential integrity constraint without setting cascade operations. Okay. මේව අපි කරලා තියෙන semester 2 වල හරි database වල. Right. On update, on delete. What are the options? Cascade, set null, no action, restrict. Sometimes there's something called set default also. Restrict means if there's a violation, don't allow it. No action is the default thing. That means ignore it. Department table එකේ නැති department ID එකක් දැම්මත් එයා save කරගන්නවා. Employee table එකේ department field එකට. By default, it is actually no action. In some databases, by default, it is restrict. But definitely, you can write set your own restriction rule. Okay. මොනවාද වෙන්නේ මේවයි. Right. On update cascade නම් මොකද වෙන්නේ? Set null නම් මොකද වෙන්නේ? What happens if it is set default? What happens if it is set null? What happens if it is restrict? That means that statement will not be executed if this violate. Right. You must know what is entity integrity violation, key constraint violation, referential integrity violation, any other domain constraint violation. These are things that we specify as our own constraints, like gender must be male or female. ඒව ගැන මම ඔයගොල්ලන්ට රෙඩි කරන්නේ මොකද ඒව semester 2 වල database වලත් කරලා තියෙනවා. Right. So even you can have constraint for drop tables. Right. Not only for data manipulation, even for data. DML, DCL, what is the other one? Data, DDL, data definitions also you can have constraint, especially for drop tables. Okay. So that means if there's a foreign key referring to your table, don't allow it to drop it. Or cascade. Then when you drop your employee department table, if it is cascade, employee table is also dropped, which is very dangerous thing to do anyway, because maybe employee table has a foreign key reference to your department table. But usually it is mostly we go for restrict. So then you must remove the foreign key in the employee table and then come back and drop the department table. That is restrict. Okay. At any time you can drop your constraints as well. Okay. Drop your constraint. Alt table, drop constraint, your foreign key constraint, primary keys, any other name constraints. Okay. At any time, you can add new constraints as well. All are alter table statements. So you can see there are constraints for DDL, DML. So assertions are also constrained, right? But that is often beyond one table. ගොඩක් අයම exist no exist ඒවා තියෙනවා. Right. So triggers කතා කරලා තියෙන්නේ based on event, condition and action. Row triggers statement, and you can have before, after, instead of. මේක අපි කතා කරා හරි. මේ refer කරන new value. At any time you can drop a trigger as well, and remember for updates you have the old and new value. For insert there's no old value, for delete there's no new value, but still you can refer to them, but then those will have no null values. But update you have the old and new value. right? New මෙතන පාවිච්චි කරලා තියෙන dot notation එක Oracle වල නම් පාවිච්චි කරන්නේ colon notation. හරි. මොකද මෙයා මේ පොතකින් අරන් දාලා තියෙන්නේ ඔයගොල්ලන්ගේ post coordinator. ඒකට එතන prefer කරලා නැහැ Oracle වලට පරණ පොතක් නේ අනිත් එක. Okay. Right. So now we have a revision two topics. Right. So let's look at 2024 paper. And I will mark those as well. So we can do we can do the A part. We can do the B part. Sorry, A part 1. Write an SQL statement to add new. Yeah, we can do the second part. Trigger. We can do the third B part. Right, C part we can't do yet for distributed databases. Yeah. Yeah, we can do these parts. First, I will mark the questions. Okay, first I will mark the questions. So then 2023, it's distributed database question. Right, we can do the B part. Let me mark we are going to do. So the D part we can do. E part we can do. Yeah, those things we can do. Then 2022 paper. So we can do 1A. Right. Constraints. B A1, A2, trigger. We can do third one. Right. So that B we can't do. It's distributed databases because we are going to do a revision on that. Yeah, I think that's it. Yeah, so let's do those things. Right, 2024. Question 1A. Let me save these things. Right, 2024 question 1A. Consider the following relation. Star system in the Interstellar Research Institute database that stores the details about star systems. You are expected to design a relation that is stable named planet. for the Interstellar Research Institute database. The relation will store details about planet discovered in different star systems like solar systems. The primary key is underlined. Okay. The planet relation contains 6 attributes. Planet ID. Let me mark those things. Planet ID. Uh, int star system ID, int planet name, Vacha, radius, decimal, habitable Boolean, planet type Vacha. Why again planet? Okay. Planet ID is the primary key. So this is the primary key of the planet relation, and star system ID. What is star system ID? Yeah, this one is the foreign key. So this is the foreign key. This is the primary key. So this is the foreign key to star system relation. Star system. Right. Write an SQL statement that create the planet relation. That is this table. This is the star system table, right? So they have given the star system table structure. This is the foreign key to this primary key. What you are supposed to write is the table planet, SQL statement planet, relations, and ensure the following conditions are met. Okay. So every attribute in the planet relation must have a value. That means not null. So that means not null. Presence of null value is not allowed. So make sure that your uh, every attribute in the planet, every attribute. That means every attribute must be not null. Okay, every attribute. That is a planet ID, star system ID, planet name. Right. So you will see in the answer, every attribute must be not null. You can see not null, not null, not null, not null, not null. Okay, that is first thing. So otherwise you will lose marks. Next, the planet type attribute, of course, you need to create table. You have learned this in semester 2, right? Create table. Then primary key, you can create the primary key in the field itself or separately as a separate statement or as a constraint, right? Constraint, PK, blah, blah, blah. Okay. Any approach. Okay. But make sure every field is not null. The planet type attribute in the planet relation must only allow one of the following predefined values. That means check constraint. Check whether value is either this, or this. Okay. So create table planet, right? And close it, semicolon. Then planet ID in primary key. That is easy because simple primary key. You don't need to create a separately. You don't need to write here, right? So then you can see uh, all are not null. All are not null. And then this one, planet type. That is planet type. Yeah, planet type. It must have a check constraint where planet type in either this or that or the other one. Right? You can create a name check constraint, but the easier thing is because it's referring to the only that field, you write it in the same field itself. Right? Check, but again you need to say your field name in this, or you can write a separate check constraint below. Okay, like this constraint planet check unique check planet type in blah blah blah. But easier thing is doing that here. Values in the radius should be positive. That again you can use a check constraint in the radius field. Check radius is greater than 0. Okay. The planet name attribute must be unique within the same star system. Right? Same star system. So that is different, right? Star system is this, not it doesn't say it is unique. Unique within the same star system. That means star ID, star system ID, uh, planet name combination must be unique. That is what it means by within the same star system. Like different star systems, you can have the same planet name. So that means planet name, uh, star system ID combination must be, you can't have star system ID 1, Jupiter. Again, star system ID 1, Jupiter. No. But you can have star system 2, Jupiter again. So that combination must be unique. So I think that is a tricky one. Okay. Right. So let's see how it is implemented. You can see you can't specify it here, right? You can't specify it in the planet name because it's referring to other field also. So you need to go for a name constraint. Constraint unique planet name, unique planet ID and planet name. Make a planet name එකට විතරක් තියෙන එකක් නම් මෙතන ලියන්න තියෙනවා unique කියලා. Just unique, right? Sorry, just unique here, but it's combination of two fields must be unique. So therefore you need to go for a name constraint, a unique constraint, but involving two fields. Okay, so be very careful. This examiner is very serious. I'm very serious. Okay. Remember, the subject used to be in the final year, semester 6. And a lot of students fail this subject. Now it's in semester 3. It's very tough, I know. Okay. Because you need to think. Of course, maybe you can easily get a C, but getting a plus, you need to be equal as your examiner. Okay. Right. Next one. Star system ID should be the foreign key reference, that is easy for foreign key constraint say FK star system. Then you can see, okay, let's see. Should be the foreign key reference from the star system relation where updates of star system IDs relation should automatically propagate. That is on update cascade. Okay. However, deletion in the system relation is prohibited. That is on delete restrict. Okay. On delete restrict. So constraint, just give any name. It's a foreign key constraint. It's not a unique constraint. Your field is star system ID references star system tables primary key. Okay. And on update cascade, on delete restrict. Okay. So if you know your subject, you must get full marks for this. Full marks, right? All 10 marks. Right. Now you can see I have underlined all everything. Right? Not null. This check constraint, this check constraint. This unique constraint must be a name constraint because it refers to two fields. And of course the foreign key. මේවා නම් ඔයගොල්ලෝ semester 2 වලම ඉගෙනගෙන ඉවරයි. Foreign key constraint ලියන විදිය, primary key constraint ලියන විදියනේ. Right. Any questions? So then we can go to second part. Write an SQL statement to add new constraint to validate the condition. It's a new constraint to validate the condition given below. When data is entered into planet relation is the relation that we just now created. Planet relation that you have created in A1 above. Okay, A1 above. A habitable planet must have radius between 5,000 to 15,000. Right. So now already this table is created. This is a simple constraint. This is not a trigger. I don't think you need a trigger for that because it says constraint, right? Yeah. I don't know if the examiner expect a constraint or update to this table. I will do update to this table. Update planet, not update, alter planet, add constraint, alter planet, add constraint. You can give any name for constraint, radius constraint or whatever. Then you can see check radius greater than 5,000 and less than radius less than निकाल लिया ना भाई, radius greater than 5,000 and radius less than 15,000. So I will write it as a update alter statement. I don't know if the examiner expect as a trigger, but I don't think so. Okay. This examiner has created an assertion for that. I don't know why. I don't know why do you need assertion for this kind of things? Okay. Because simple constraint will do it. Right? This is between 5,000 and it says habitable planets, right? So not every planet. So remember we have something called habitable or not. So that of course you can't write it as a check constraint, right? Because in the constraints you can't write if else part. Right now only I found it. Okay. So there's a field called habitable. When habitable is true, only you need to enforce this, right? So that kind of things you can't write as a table level constraint. Even when you create that, you can't write because you can't have if conditions here, right? So this can be, you can write it as a trigger also, right? Insert trigger, because insert trigger you can check those values, because when you insert you get the habitable field also, right? Radius field also. So I don't know why the examiner has written assertion, right? Even trigger should work, but definitely you can't write it as a constraint here because it refers to two fields, right? If it is habitable only, so you can't write if else type of things here. So therefore, I will go for trigger, but examiner has written a assertion. But examiner has not mentioned whether you need assertion, right? It just say constraint. Okay. I don't know. For some reason, examiner has given an assertion. Of course, create assertion, give it a name. Check not exist. Remember, හැමතිස්සම අපි exist not exist ඒවනේ යන්නේ assertion වල. Select all from planets where habitable equal true and ඔන්න මෙහෙම ලියන්න බැරි හන්ද අතන කරන්න බැරි වෙන්නේ. And radius less than 500 5,000 නෙමෙයි අතන මේක and වෙන්න ඕන. Right? Because it says radius between 5,000 and 15,000, right? So that means this is wrong, definitely wrong. This must be and this. Okay, මේක අපිට මේ ට්‍රිගර් එකක් විදිහට ලියන්න පුළුවන්. මෙයා ඔක්කොම රෙකෝඩ් ටික බලනවා. එතකොට assertion එක fail වෙනවානේ. insert එක update එක කරා. Okay, because this says data entered. Data entered කියන්නේ මම හිතනවා insert කරද්දි බලම ඇති. Insert and update. Right. අපි නිකමන මේක chat GPT දාලා බලමු. අනිවාර්යෙන් මම හිතන්නේ යා assertion එකක් නැතුව trigger එකක් ලියලා දෙයි කියලා. Okay. Let's give it to chat GPT. It says even you can write a check constraint, right? And check constraint already. Alter table planet, add constraint, give it a name, check habitable false. Oh, can we use over here? Between use කරන්න පුළුවන් අර and දාන වෙනකොට. I don't know whether it's possible in all the databases, but ChatGPT even says even this kind of a constraint will work. Check constraint can be work. That means you can check more than one thing using O. Habitable false or or you can say habitable true and හරි habitable false so මේක නැත්නම් habitable true and අය කියන්නේ check constraint එකක් ලියන්න පුළුවන් මෙහෙම ලියලා. හරි මම දැන් දැන් හිතේ මේ ඕ දාන්න පුළුවන් කියලා. Anyway, so that means even alt I also first try to do alter table but I thought you can't check two fields but it looks like you can use and or. Okay. Uh, yeah. Yes. So I don't know why assertion is required, but anyway, X7 has given assertion. Okay. This paper part 1 and part 2 is the total 200 marks. What is the total of the second? Usually it should be 50-50. That means 200 means total divided by two, percentage is 200. Your total divided by 200. Okay. So usually it should be yes, maybe 100 or 50-50. Right? So that is a 1 hour, right? Right. So let's look at the next question. So anyway, examiner has given assertion, but even check condition, no. Check condition also you can use O, but uh, even trigger, all are going to work. Okay. So shall we ask, can you write a trigger? Trigger. So this is the trigger. Create trigger this before insert for each row because there can be multiple inserts. If habitable equal Y and new radius less than 5,000 or new radius greater than 15,000, then uh, it says SQL state 4,500. That is basically abort it. You need to abort it. මේක ටිකක් technical වැඩක්. අර statement එක abort කරන්න. Okay. Because you need to prevent that. අර prevent කරන්න අමාරුවන් තමයි මෙතන මෙයා මේක මෙහෙම ලිව්වේ constraint එකක් විදියට. ඒතර constraint එක fail වෙනකොට වැඩ insert වෙන්නේ නැහැ නේ. Okay. So this is little bit technical. And you need to write it for before update also. Before update. ChatGPT just make it SQL state 4,000, 45,000. Okay. And set a message. Okay. So let's make it to a Oracle trigger. අරක MySQL වලට දුන්නේ. So it says trace application error. හරි. Oracle වල වෙන විදිහකට කරන්න කියන්නේ exception එකක් throw කරන්නලු මේ මොනොත්. So that means there are multiple ways of doing this. Right. So let's ask to write assertion also. Right. එයා කියන Oracle assertion support කරන්නේ නැහැ කියලා හරි. Forget about that. Theoretically. Right. So this is the examiner's answer, right? Create assertion. Right. Give it a name. Check not text is select all from blah blah blah. So if this assertion is going to be fail for before after doing any of these operations, insert update, it will be rolled back. Right. It will be rolled back. So anyway, better to know all these possibilities, right? You can write assertion. This is a little bit more technical because you need to stop insertion. In Oracle, it's basically you need to raise an exception. And even this kind of, this is the easiest thing. I don't know why examiner hasn't considered this one. You can add a constraint like this check constraint, but it must be a name constraint because you are referring to two fields. Habitable field, radius field. Check constraint එක දැම්මම නිකම්ම abort වෙනවා. ඒ check constraint එක fail වෙනකොට insert එක update එක වැඩ කරන්නේ නැහැ. Right. So, right. I hope examiner will specifically ask you to tell whether it's a check or whatever you want, right? නැත්නම් multiple ඒවාට උත්තර examiner marks දෙන්න ඕන. Right. B. ඊළඟ එකේනම් trigger එකක් කියලා තියෙනවා කෙලින්. මේකේ මේ කියන්න දෙන මට constraint එකක් වෙනුවට කෙලින්ම assertion එකක් ලියන්න කියලා. හරි. It needs simply say add a new constraint. Okay. අපි තාම බලන්නේ මේ assertion එකක් කියලා ගන්න hint එකක් දීලා තියෙනවා. ඒකට එහෙම දීලා නැහැ. හරි. Just say write a SQL statement to add new constraint. ගොඩක් අය ඉස්සරම ඔළුවට යන්න ඕනේ. එතකොට update alter table එකක් කරලා මේ check constraint එකක් දාන්න පුළුවන්ද කියලා. ඊළඟට trigger එකක් දාන්න පුළුවන්ද? ඊළඟට assertion ලියුම තියෙන වාසිය තමයි අර insert update delete ඔක්කොටම වැඩ කරනවා. වෙන වෙනම ලියන්න ඕනේ නැහැ. හරි. අනිත් මේ වගේ abort කරන වැඩවලදී triggers ටිකක් අමාරුයි. trigger එකේ කියන්න ඕන මේක නවත්තලා error එකක් raise කරන්න කියලා. හරි. මේවයි එහෙම ලියන්න දෙයක් නැහැ. මේක fail වෙනකොට operation එක නවතිනවා. Assertion වලයි check constraint වලයි. Okay. Right. So now let's move on to our B part. Consider two relations order customer given below related to online shopping platform. Right. Order customer must can every order must have a customer ID as the foreign key. Right. So it's one to many. Customer can have many order. Order is always referring to a customer. Write a trigger that adds reward points to the customer relation. Right. So that is reward point. When an order status in the order relation is updated as completed. So whenever order status is updated to completed, you need to add reward points. Right. So that is definitely a trigger, right? The best thing to do is write a trigger, update trigger. The reward point should be calculated as 1% of the total amount. So you have the total amount of the order, right? So you take the total amount and take 1% of that and update the reward point. That is reward point equal reward point plus that 1% value, right? That 1% value, you can keep it in a variable, okay? Of the order and added to the existing reward point of the corresponding customer. So this is cursor, right? It says on update, right? On update, but better to write on insert as well. ඒකත් එතනම දාන්න මොකද insert එකේදීම කෙලිම ගියොත් එහෙම නේද? Right? But I think examiner expect only on update. On update. So you need to take the before value. Basically, you are writing it for the order, right? Not for customer. Therefore, you don't need to take the before value, right? Because you are writing the trigger to order, right? Trigger to the order. Okay. Right. So create or update trigger. Give it in any name. You can see after update. Yeah, insert එකට බලාපොරොත්තු වෙලා නැහැ. After update on order table. Order status කියලා තියෙනවා. නමුත් එහෙම කිව්වත් කමක් නැහැ. එතකොට that means for this table this field, right? This table this is little bit pseudocode. මේක 100% oracle උත් නෙමෙයි. හරි? Then for each row, then you have the begin end. You take the order status, new value. අතන colon පාවිච්චි කරලා oracle notation එක පාවිච්චි කරලා තිනවා. If it is completed, then update this table. Right? So there you take the reward point equal reward point plus එතන new all කියලා ලියන්නේ because this is standard SQL. But you need to use the new total amount into 0.01. That is the updated value. So this is added to this. Where customer ID is your new values customer. ID. Okay. So that is pretty standard trigger. Okay, pretty standard trigger. So make sure when you refer to the values, you refer to them as new, because either you must refer to as new or old. Make a new, no that old na taula na. Let's go for new. This must be definitely new total amount. Uh, okay. But here you don't need to say new and old, because this is your other table. This is standard SQL, right? This is standard SQL. Now these are in your customer table, right? But these values are coming from your order new SQL statement, right? New SQL statement. That is why you need to refer to as new. Here also new custom ID. Okay. And of course we have used if else. If status is completed, මේකත් new වෙන්න ඕන මොකද මෙයාත් එන්නේ මෙතන ඉන්නේ. හරි. New order status, new total amount, new customer ID. If they end if and end. මේක ටිකක් mixture of Oracle and pseudocode. හරි. Examiners ට ගොඩක් අයට උතෙන්දී perfect syntax බලාපොරොත්තු වෙන්නේ නැහැ, because examiner knows that there are differences in Oracle, MySQL, Microsoft SQL, but reasonably correct syntax. Okay. Right. So that's 2024 paper. Second paper. Right. Right. So shall we go for 2023 second papers? There's a constraint question. Yeah, D part we can do. D part. Consider the following relation employee. You can see the questions are very big. Consider the following relation employee in the company database. So employee table in the company database that stores details about employees. There are requirements to create salary table, another table, which contains information about monthly salaries of the employees within the company. So this is the structure of the employee table. Most probably they will ask you to write the create statement for salary. So employee ID is the primary key, employee name, start date, position, email, phone number. The salary relation or the salary table contains 6 attributes, right? So you must have 6 attributes. Salary ID int, employee ID int, salary amount decimal, මේවා පාවිච්චි කරන්න. Currency වාචා, month int, year int, salary ID is the primary key. So singles become the salary ID again primary key කියලා not null primary key. Key of the salary table, and employee ID is the foreign key. So make sure you have the foreign key constraint referring to the employee tables, employee ID. Okay. Write a SQL statement which creates salary relation ensuring the following conditions. Every attribute in the salary relation must have a value. That means every attribute must be not null. Okay. Now what structure උරුවට එන්න ඕන. Create table salary. Every salary ID is in primary key. ඔතන not null කියලා දැම්මන වැඩි හොඳයි. ඒක optional ගොඩක් වෙලාට. But better to write in not null primary key. Then all the other fields must have the data type and not null. Not null data type. කියලා තියෙනවා data type එක. අර type දාදී වාචා වගේ වට අනිවාර්යෙන් value එකක් දාන්න. හරි decimal වගේ වට width එක. This is total 10 two decimals. right? ඒවට ලකුණු කපයි නැත්තම් month int not null ඒවත් data type දීලා තියෙන. int වලට දෙන්න ඕනේ සමහරවිට int වලටත් දානවා අපි size එක සමානලා. And foreign key of course reference to employee tables employee මේ ටික පස්සේ කියලා. දැන් හරි. not null ටිකක් දැන් හරි. දැන් මේ ටික තමයි ඔය යටින් කියලා ඇත්තේ. Value for currency in the salary relation should be LKR or USD. So that means check condition, right? Check condition. Check condition for what? Currency, right? LKR USD. For currency, whether it is in LKR or USD, right? Value of salary amount should be positive number. That is again check condition in that field because single field thing. It you just check whether salary amount greater than zero. Salary amount field itself you can do it. And then here we one update. Okay? Employee ID should be the foreign key reference to the employee relation. Yes, where changes to database of employee relation should automatically propagate to salary. That is on update, on delete, cascade, right? On update, cascade, on delete, cascade. That's it. Again, you must get full marks. Full marks. Right, second part. Write a SQL statement to add new constraint කියන්නේ යා මොකද්ද දන්නේ නැහැ බලාපොරොත්තු වෙන්නේ assertion එකක්ද trigger එකක්ද කලින් නම් constraint කොහොම යාලියලා තියෙන්නේ assertion එකක් 24 paper එකේ. Right, write a SQL statement to add a new constraint to validate the condition given below. When data is entered into salary relation that you have created, but the when data is entered කියලා තියෙනවද මං හිතන්නේ again the examiner expect assertion. Okay, I don't know because it's same terminology. Right, the value of the month should be between 1 to 12. Value of the year should be between 200 2000 to 2100. මේක නම් ඉතින් අර ආයි අපිට මෙතනටම දාන්නත් තියුණා. alter table එකක් ගහලා. Because month and year is, yeah, it's a check constraint. Check constraint. So that also work, right? මේකම alter table එකක් ගහලා මේ constraint එක දාන්න තියුණා. Okay. හැබැයි දැන් මේව තීන හන්දාවට name constraint විදිහට තමයි ලියන්න වෙන්නේ. මොකද දැන් field හදලා තියෙන්නේ. That is the easiest thing, but I don't know whether examiner is expecting anything fancy. මොකද trigger ලිව්වොත් එමාට errors raise කරන්න වෙනවා. දැක්කනේ Oracle වල එක විදියකට MySQL වල errors code එකක් set කරා. එහෙම නැත්නම් ඉතින් assertion එකක් ලියන්න. assertion එකක් ලියුවම ඉතින් error එකක් ආවොත් auto නවතිනවා. Right, I will go for alter state. මේ වගේ වට මොකටද assertion මේ assertion ලියන්නේ නේද? alter table එකක් දාලා name constraint දෙකක් ලියපුවා හරි. Okay. Yeah. මේ වෙලාවේ examiner alter table එකක් ගහලා තියෙනවා. මොකද මේකට මම දැන් අර වෙලාවේ check assertion එකට ගියේ කියලා. අර වෙලාව මම දැන් assertion එකට ගියේ error එකක් raise කරන්න වෙන හන්දා. හරි මෙතන error එකක් raise කරන්නේ නැහැ මම හිතන්නේ. පේනවා. මෙතනත් error එකක් තමයි raise කරන්න ඕන. right. නෑ මෙතන error එකක් raise කරන්න ඕනේ නැහැ. මොකද මේක alter table එක. trigger එකට ගියොත් තමයි errors raise කරන්න ඕන. කලින් එකත් අපිට ඕන නම් කරන්න දෙන්න මේ පේනවා මේ check constraint එක and use කරලා තියෙන්නේ. check constraint දෙකක් clear නැහැ මම හිතුවේ දෙකක් clear කියලා. constraint දෙකක් clear එක නෑ එක constraint එක ඇතුලේ and use කරන්න පුළුවන්. right, add constraint, name constraint because this is referring to two different things and also the fields are already created. දැන් මේ fields හදලා තියෙනවද මෙතනට constraint add කරන්න බෑ. name constraint තමයි දාන්න වෙන්නේ. හැබැයි මුලදීම මේවනේ වෙනම ලියන්නත් තියුණා. හැබැයි මේක field දෙකම එකට දානවා නම් අනිවාර්යෙන් name constraint එකක් වෙන්න වෙනවා. check month between 1 and 12 එහෙම නැත්නම් අර and එක දාලා ලියන්න ඕන. and year between 200 to 2100 and between කො මේවා inclusive inclusive, right? That is good, right? So that is the best way to do. Just alter table and ඔකට කලින් 24 එකෙත් ඔකම කරන්න තියුණා හැබැයි යා මොකද check constraint එකේ වල multiple fields බලන්න පුළුවන් and දාලා හරි and දාලා right. See e part. Consider two relations, video and comment, given below. related to video streaming platform. Primary keys are underlined and foreign keys are in italics. Right? Primary keys are underlined and foreign keys are in italics. This is primary key. This is foreign key. Video ID. Write a trigger that execute delete cascade operation on comment. මම කොහොමද ඇක්චුලි ඔය triggers විදියට තමයි යන්නේ. හරි? Execute වෙන්නේ. Table after the corresponding video record is deleted from the video table. So that means when you delete a video, all the comments related to that video ID must also be deleted. Right? Write a trigger that execute delete cascade operation on comment. That means when you delete a particular video, all the comments related to that video must be deleted from the comment table. Okay? That is simple trigger. මේක error එකක් නෙමෙයි මෙතන තියෙන්නේ අරක මකද්දි මෙයන් මකන්න. Right? So this is a trigger on video table on delete. Right? Create trigger, give it a name. After delete on video table for each row. ඒක කොහොම syntax එකේ තියෙනවනේ. Begin end. So delete from comment where video IDs, all video ID. මොකද new එකක් නැහැ delete වෙලා. So those are very important. So when you have a delete statement, there's nothing called new value, only old value. For insert, there's no old value, only new value. Update only we have old and new. So therefore, if your trigger referred to related to a delete, and if you want to take the value, it must be old value. And it must be after delete. මොකද අර delete කරලා ඉවරලා තමයි මේක comments මකන්න ඕන. Comments මකලා video මකන්නේ නැහැ සාමාන්‍යයෙන්. මොකද video එක මකලා ඒක success නම් තමයි මේක ඒතකොට trigger වෙන්නේ. Right? අපේ after කියන එක ලකුණු දීලා දෙන්න. Each row 1 marks, begin and 1 marks. So correct SQL statement 1 marks. All කියලා කියනවා කී දෙන්නෝ නැත්නම් ඒ ලකුණු දෙන්නේ නැහැ. So be serious, right? Be very, very serious. Right? So that is why I always recommend you to try to go for your A's, B's. So that shows that you are very serious. You are very serious about exams, right? So it doesn't mean that you are going to be very serious about your other things, life, career. But at least if you are serious about one thing, there's a better chance that you are serious about other things also. At the same time, make sure you are serious about all the things, right? Not only exams, your career, life. Right. So that is 2023 paper. Right. 2022 paper. But when the evolution of databases, no question here because those are only in MCQs. මොකද ඒවයින් අර අහන්න ලියන්න කියලා දෙය අහලා නැහැ. අඩු ගානේ object data class structure එකක්වත් ලියන්න කියලා නැහැනේ. Right. 1A. Consider the below details regarding student relation in a student management system of a university. The relation student should store each student's basic details, including the student's first name, vacha, last name, vacha වලට value එකක් දාන්න vacha 20 වගේ. Last name, address, contact number, birth date, that is date, gender, cha. Okay, cha ගන්න කියලා තියෙන්නේ. cha කියන්නේ fixed bit එකක්. හරි variable ඒවා නෙමෙයි. මොකද ඔකට එන්නේ male female වගේනේ. And registered date. Each registered student having student identification number. එහෙම අපි එතන කියලා නැහැ. දැන් කියන integer, which is a primary key, single field primary key. Write the complete SQL statement for the student table creation, including the required constraints to satisfy this. Null values are not permitted for any of the attributes, so all the fields not null. The registration date of each student should be default system date. So default, right? Default මට මතක නැහැ හරියටම system date එක කියන්නේ කොහොමද කියලා නිකන් ඒක මතක නැත්නම් නිකන් හරි ලියන්න system date කියලා. හරි current date හරි මොනවා හරි කියලා ලියන්න. මතක නැත්තම් මොකද මේක database එකෙන් database එකට මේක වෙනස් වෙනවා. හරි සිස්ටම් ඩේට් එක ගන්න ඉතින් නැත්නම් ලියන්න සිස්ටම් ඩේට් current date වගේ එකක් ලියන්න capital වලින් හරි where each record is entered into SME system date ඒක වෙන පාවිච්චි කරන system date වගේ වචනයක් නැත්නම් current date මම හිතන්නේ ඔතන system date අනිවාර්යෙන් database එක වෙනස් ඇති then age which is difference between the default system date and birth date එක අපිට එනවා නේද ඔය date birth date එනවා is restricted to integer number greater than 18 that means age must be bigger than 18 කියලා තියෙනවා නේද date diff එක ගන්න විදිහ කියලා තියෙනවා the function date diff මොකද ඒවා date difference එකක් ගන්න තියෙන්නේ ඕවාට මතක තියාගෙන යන්න බෑනේ so assume that there's a function called date diff you have the in parameters and this should be the out parameter interval returns the difference between two dates the value year for the parameter interval of they can use the value year I mean parameters විදියට මේ value years පාවිච්චි කරන්න මොනවද මොන years පාවිච්චි කරන්නේ එකක් system date එක අනිත් එක birth date එක හරි date එකෙන් හැබැයි දැන් year එක කඩලා ගන්න වෙනවා නේද නෑ නේ date diff නේ හරි එයා කඩලා ගන්න එයා කඩලා ගන්න right so that must be additional constraint right additional constraint use this function there okay right so create table all the fields must have the not null 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 and student id is the primary key auto increment දාලා තියෙනවා කියලා නෑ නේද කියලා තියෙනවා auto increment දාන්න කියලා each registered student is having a student identification number integer which is the primary key එහෙම කියලා නෑ ඒකන්ද ඒකට auto number නැම්බෙත් නැතත් ලකුණු දෙන්න ඕන හැබැයි auto number දාන එක හොඳයි දැන් ගොඩක් අය auto number තමයි යන්නේ primary key හැබැයි අනිත් papers වල auto number බලාපොරොත්තු වෙන්නේ නෑ හරි right so then that is auto number not null all the fields this one is also not null gender char not null char නම් වාට සාමාන්‍ය value එකක් දානවා char වලත් හරි fix value එකක් මෙයා ටිකක් වෙනස් විදිහට අරන් තින්නේ හරි එයා use කරලා දෙනවා check date diff ආය අරන් තින්නේ current time stamp කියලා right current time stamp and date of birth right current time stamp මෙතන තියෙනව නේද default is current time stamp ඒතර current ඒකයි current time stamp හරි sys date හරි මොනාරි ඕකට ලකුණු දෙනවා අනිවාර්යෙන් හරි current time stamp කියලාම ගත්තේ නැහැ කියලා ලකුණු නොදී ඉන්න බෑ because these are different in different databases Oracle MySQL right so they just use whatever reasonable constant name for that okay just assume there's a constant for that in every database right so default is current timestamp or sys date or current date okay or current date type right මෙතන auto increment කියලා තියෙනවා මෙන්න check constraint එක එතකොට මෙතන දාලා තියෙනවා default constraint එක date diffuse කරලා තියෙනවා හරි you need to check that return value is it greater than 18 if it is not greater than 18 this check constraint will fail and insert will not work insert to update will not work give you error right so this is the year part of the current timestamp and this is the date of birth so this is the return value actually right return value this is the in parameters date of birth and the current timestamp නිකන් year කියලා එකක් දීලා තියෙනවා එහෙනම් year කියලා එකක් මේක පේන්න නැහැ හරි මෙයා කියලා තියෙනවා year කියලා ගන්න කියලා because you need a return value right yeah it says use the value year for the placeholder parameter interval මේ interval එකට year කියලා දෙන්නලු බොරුව තමයි හරි මොකද මේක return එකක් ගන්න බෑනේ check constraint එකේ එයා කියනවා මේක year කියලා දෙන්න කියලා. හරි year කියලා දුන්නා මොකද වෙන්නේ නැත්තේ date diff එක return කරන්න නැත්තේ year difference එක. හරි year difference එක return කරන්න නැත්තේ. ඒකයි year කියලා දෙන්න කියලා ඇත්තේ. හරි. Rather than the year, date, month, full difference. So when you say year, assume it the date diff function return the year part only, and that must be bigger than 18. ඒතකොට අතෙන්ට ලකුණක් විතරයි දෙන්නේ නැත්තේ. හරි මේක හරියටම ලිව්වේ නැතත් ඔයාලට සෑහෙන ලකුණු ප්‍රමාණයක් එකතු වෙලා මේ වෙන්නේ. මොකද මේක එකපාරට ලියන්න මටත් ඔළුවට එන්නේ නැහැ. හරි. මේ කියලා තියෙන මොකද කියලා එකපාරට තේරුන්නේ නැහැ මටත් මේ කියලා තියෙන year කියලා මෙතෙන්ට යවන්න ඒක පැරාමීටරයක්. එතකොට ඔයාලට year difference එක දෙනවා වගේ. එතකොට නේ ඔයාලට greater than 18 කියලා බලන්න පුළුවන්. හරි. මේ auto increment එකට ලකුණක් දීලා තියෙනවා. හරි. auto increment එකට ලකුණක් දීලා තියෙනවා. Not null 0.5 marks. Other fields 1 mark. Defining the primary key 1 mark. මෙන්න මෙතන තමයි හරියට කල්පනා කරලා ලියන්න ඕන. හරි. යා කියලා තියෙන එක ගන්න. මේ examiner has not expected that you know what is date diff. But you can use it, but now only I found that you need to send it as year so that you get the year difference, which you need to check whether it's greater than 80. Okay. That part is little bit tricky. ඒකෙදි එවෙලේ ඔළුවට આવොත් හරි. ඕක දැන් ඔයා ස්ටඩි කරා පාඩම් කරා කියලා කරන්න බෑ. මොකද මේ ඔක්කොම ඔයාලට කටපාඩම් කරන්න බෑ. Right, second one, second part. Consider that only permitted values for a gender in the student relation are M and F. Write SQL statement to enforce additional constraints called gender type on the table student that would be applied to check whether the gender of all the students belong to any of the above. හරි check constraint එක ලියන්න තියෙන. ඒක ඉතින් කාට කරන්න පුළුවන්. හරි. Right. So then you have a trigger. Right. Trigger එක තමයි ඔයාලට දැන් ලියන්න පුළුවන්. හරි. Triggers කියන විදිහට අපි කතා කරලා තියෙනවා. උත්තර දෙකක්ම දීලා තියෙනවා. SQL notation එකට එකක් දීලා තියෙනවා. There is MS SQL, this is Oracle. Right. This is Oracle. Okay. ඒක හොඳයි. හරි. ඒ කියන්නේ examiner always conscious that different syntax exists, right? So therefore you can stick with Oracle. Right? Stick with Oracle. Right. So this is distributed databases. Okay. Right. So we'll stop at this point. You have the evening session. Evening session will take maybe another topic like transaction handling. Okay. Or transaction handling and distributed databases. And then do the past papers for those. Right. එතකොට අපේ ඊළඟ දවසක අරගෙන අපිට කරන්න පුළුවන්. You have tomorrow morning also, today evening, tomorrow morning. Maybe tomorrow morning we can take another topic, and maybe Monday and Tuesday all the MCQs. Okay. So then everything is done. Okay. Right. We'll stop at this point, right? Thank you.